The goto statement in C allows for an unconditional jump to a labeled statement within the same function. It's been a part of the C language since its creation. However, it is a controversial control flow mechanism. The goto statement can make code difficult to understand and maintain. Here's an example. We declare an integer I and initialize it to 0. The label start_loop marks the beginning of our loop. If I is greater than or equal to 5, the program jumps to the end_loop label. Printf function prints the value of I, then I is increment. The program then jumps back to start_loop. Finally, the label end_loop marks the end of the loop, and the program returns 0. The goto statement has a couple of common use cases. One use case is in error handling. Goto can be used to centralize cleanup code when errors occur. For example, you open a file using the fopen function and assign the file pointer to the variable file. If file is null, indicating an error in opening the file, the program jumps to the error label using goToError. The program closes the file using close function and returns 0. If there was an error opening the file, the program jumps to the error label. The printf function prints an error message. Finally, it returns -1, indicating an error. Another common use case is breaking out of nested loops. Goto provides a way to exit multiple loops at once. Find_value function takes a 3x3 integer matrix as its argument. The program iterates through the rows and columns of the matrix. If the element at row I and column j is equal to 42, the program prints the row and column indices where the value was found. Then, the program jumps to the found label using goToFound. The goto statement has several dangers. Using goto can lead to spaghetti code that is difficult to follow. It also makes debugging and maintenance more difficult. Goto can lead to unintended side effects. It obscures program flow and logic. Furthermore, it complicates compiler optimizations. Instead of using goto, use structured control flow statements like if, while, and for loops. For error handling, functions with early returns are preferable. For breaking out of nested loops, boolean flags can be used. In the code snippet, instead of using goto for nested loops, a boolean variable found is initialized to false. The outer loop iterates as long as I is less than in and found is false. The inner loop iterates through the columns. If the condition is met, found is set to true, and the inner loop is exited using break. When using goto, only jump forward, never backward. Use descriptive label names. Limit its use to error handling and cleanup tasks. Always consider alternative solutions first. Document why goto was necessary in the code. Keep the scope limited and local to the function. While goto has legitimate uses, it should be used sparingly and with caution. As Brian Kernighan and Dennis Ritchie said, goto statements should be used rarely, if at all. Nevertheless, we believe that goto still has its place in system programming. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.